All right, so today we are going to start with an equation or a function, and it says we're going to use our calculator and we're going to use synthetic or long division to factor out rational roots. So what I've done on my calculator, and you can pause this video at any time to catch up, but what I've done with my calculator is I've actually just put all three of them in so I could make this video a little bit shorter. But if you see the equal sign, the first one's the only one that's turned on, so that's the only one that we're going to graph right now. So I'm going to go ahead and graph that. And then we're going to look at our zeros. If you ever need to zoom in because you have trouble seeing it, you could always window, zoom in, enter, you could see it a little bit better. And I always work left to right. The first one that I come to, I think there might be a zero here, and at -1. Sorry, at -1. So there's a couple different ways I could test that to make sure that I am correct. If I do second trace and I do value number 1, if I type in what I think that is a 0, like if I type in -1, it will tell me if x is -1, then y is 0. So that is telling me, yes, that is a 0. Let me show you that again, but I'll try one of these over here. Let's see. I think that is 0.2. So if I do second trace value and I do 0.2, it's showing me that that is not the 0. This is the ordered pair at 0.2. So really value is just telling you if x is this, what does y equal? It's just a fast way of plugging in this number to find out what y is. I use it as a quick check to see if that's an actual 0. So one more time, value, -1, it does tell me that works. So I know that x equals -1 is one of my zeros. So what I'm going to do, since it's -1, I can use synthetic division to take that out. And getting that 0 right over here is going to tell me for sure that I've, first of all, done my synthetic division correctly, and that also that -1 is a 0. Now, I was telling you before that once you get down to a quadratic, you should be able to use quadratic formula or factoring to solve what's left over. What we're going to encounter now is these are not going to be nice answers. They're going to be irrational answers. If you try to find these on here by just like guessing, you're never going to guess them, because these are answers that have square roots in them that are not perfect squares. So I have 42x squared minus 41x plus 5 left over, and I need to find the other two zeros. So I'm going to use quadratic formula. Remember, x equals, here, I'll put it up here. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So x equals opposite b plus or minus square root b squared minus 4 times a times c all over 2 times. Okay. I'm going to use my calculator to assist me simplifying this a little bit quicker. So I have x equals 41 plus or minus square root of 841 all over 84. Excuse me. And it turns out this actually is rational. So I said something about it being irrational before. I was wrong. It's rational. I just typed in square root 80. I just typed in square root 481, and it does have a square root. It's 29. It just is not very nice looking on the graph. That's why I thought maybe it was irrational. Okay. So since it is rational, I can find these two solutions. I'm going to go ahead and do 41 plus 29 over 84. I'm going to do 41 minus 29 over 84. And for this one, I get 5 over 6. And this one is 1/7. So since these do come out as nice answers, that means that this was factorable originally. I just didn't even try it because it looked terrible. Okay, so we have 3 zeros. Let's see. And 3 zeros are 5 over 6, 1 over 7, and then -1. And for doing assignments on the computer and plugging stuff in, I'm asking that you always put them in numerical order so that the order at which I type my answers in will match the order at which you type your answers in. So if we need to write zeros, then you're going to put least to greatest, -1, and then 1/7, and then 5 over 6. That's not really what I'm asking. Am I asking you? I think I'm just asking you to write it in factored form. Right. Okay. So to write this in factored form, we have to take what x equals. So, oops. And we have to set that factor equal to 0. So I'm going to add 1. And then the factor becomes x plus 1. So for x equals 1/7, the factors do not have fractions in them, because if they did, then we would see fractions up here. So since we don't see fractions up here, all of these factors are integer factors. So what I'm going to do to change this into an integer factor is I'm going to multiply both sides by 7 to get rid of the 7 that's in the denominator. So I have 7x equals 1, and then I subtract the 1. 7x minus 1 equals 0, so that factor ends up being 7x minus 1. Oops. And then the third one, x equals 5 over 6. I'm going to multiply both sides by 6. And I'm going to get 6x equals 5. Take away the 5, and we have 6x minus 5 equals 0. So that factor should be 6x minus 5. So this says to write it in factored form. Of course, I didn't leave myself a ton of space to do this. But to write it in factored form, this is originally f of x. So I'm going to go ahead and write f of x. And then I am suggesting you just start doing this from now on. Normally in class I wouldn't be picky about it, but just because you're going to have to enter answers into a computer, I want you to put the factors in the order at which the zeros are. So the first factor, I'm going to put the factor that goes with -1, which is x plus 1. And then 7x minus 1. And then 6x minus 5. So this would be our factored form. Now in the past, I've had a lot of students just make silly mistakes throughout this process. So what I'm going to ask you to do, and you can do it, excuse me, you can do it on your graphing calculator, or you can do any of this calculator stuff on Desmos since you're, in front of a computer anyway, is I'm going to ask you to go graph the original one and your factored form at the exact same time. So we're going to have x plus 1, 7x minus 1, and 6x minus 5. Oops. And so I'm going to graph those at the exact same time. And I'll also do zoom 6, so I have a, oops, zoom 6, so I have a regular window. So if your graphs completely overlap, you could go to your table, if you're not sure, you could go to your table and every single value matches up, then you've done it correctly. There are occasions where it's not going to always work out so nice, and I'm pretty sure it's this assignment where people are going to have a little struggle. So I expect some questions if this is the assignment. Oops, if this is the assignment that I'm remembering a lot of questions from last year. But anyway, so let's do another example. So I'm going to go back here, and I don't need this last one anymore, so I'll just clear that. And then, just in case I need this again, I'm not gonna clear it yet, but I'll go ahead and just turn on that equation by hitting the equal sign. I'm gonna graph it. Okay. One thing I didn't talk about that I just automatically do it in my head is this one had a degree of 3 to start, and we had three separate linear factors when we're done. Each factor, the x was a power of 1, meaning it's a linear factor. So we should have the number, the degree number should be the number of linear factors when we're done, just in case you're having trouble finding some. All right, so since this one is a degree of 4, I should have 4 linear factors when I'm done. So we're going to look here, and we're going to try to find any zeros. So I think at -3, there's a 0. Oh gosh, I could check the first one, but that doesn't look nice. Let's see. Trace 0. I think, oh shoot. So I could trace value. I think -3 is 1, and it is. So because that first one, I would have started with the left one, it doesn't look like a number that I can just guess. I ended up trying the one that looked easiest to me, and -3 does look like it works. So I'm going to use -3, and I'm going to use synthetic division. Oh, it's 51. I got so confused for a second, sorry. All right, so that works. Now, I have to find another one, and normally in class I'm going to let you struggle and I'm going to let you try to figure it out, but we're not in class. So what I notice at -3 is I notice that there is a bounce. I notice that it comes up to -3 and it does not pass through -3. That's telling me that there is multiplicity here right at -3. That's telling me there's probably 2 -3s. So I'm going to try a second -3 right off of that first one. So you're not going to use the 0 from before, so I like to cut that off and say don't look over there. And I'm going to put a second -3 off of that answer. Bring down the 1. And yes, in fact, another -3 works. So we have 2 zeros that are both -3. Now, once we get down to a quadratic, then I expect that you factor or use quadratic formula or complete the square if you would like to solve this. I'm looking at it right now and it does not look factorable because of the 1. There's no way I'm going to get a 5. So I'm going to use quadratic formula. X equals opposite b plus or minus square root b squared minus 4 times a times c all over 2a. So it looks like I get negative 5 plus or minus square root 21 over 2. So before I go any further, I'm just going to like double check to make sure that that really is one of the answers. And I could do it by plugging it back in and checking it that way, but to me that looks difficult. So I'm just going to find out what this answer is as a decimal. Okay, so they're both negative. The furthest one to the left is negative 4.791287847. So now I'm going to go to my graph, and I'm going to actually find this 0 by doing second trace, and we're going to use 0. And it asks for a left bound, so I need to pick anything that's to the left of this. So that looks like it's around negative 5. I'm going to make sure it's definitely to the left. I'm going to pick negative 6. And it's hard to see, but there is this little line that shows up with the arrow. And now I need to pick something that says right bound. Oh, and I hit enter to get the right bound. I'm going to pick something that's definitely to the right. Looks like negative 4. I mean, you can pick 0 if you want. But it looks like negative 4 is to the right. And now it's saying, all right, the computer's or the calculator's going to look in between this section. What is it really close to? It looks like it's close to negative 5, so that's my guess. And it tells me negative 4.79128, and that's what we had gotten on the other side. So it does look like I've done my work correctly. So now we have 3 zeros, and we have to write our we have 4 zeros, 3 of them that are different. But we're going to write this in factored form. So if I have x equals negative 3, and remember I have this 2 times, then I'm going to move the negative 3 over by adding it, and I get x plus 3 equals 0. Okay, so our factor is x plus 3, and because there's 2 of them, we will have that squared. And then we also have x equals, we have negative 5 minus square root 21 all over 2. We also have x equals negative 5 plus square root 21 over 2. So, set that equal to 0, we would want to subtract that entire thing from both sides. So if I subtract that entire thing, that is going to be distributing the sign. And so I'll have x plus 5 plus square root 21 over 2 as a factor. And same thing over here, we're going to subtract it. So that will distribute the sign when I subtract it. And I'll have x, and then we'll have plus 5 minus square root 21 over 2 as that factor. So factored form, oh, this one's a g, I'm sorry, it's not f of x, g of x. Excuse me. We think about putting this one in order. Let me think how I would have you do it on. Yeah, I'm just going to have you keep it the way you see it on the calculator. So when we look at the calculator, because if we don't type these in the exact same way, it'll mark them wrong, and I don't want that to happen. So we're going to type it in left to right. So the left one would be this middle where it was -5 and it was minus the square root 21. That's the left one. And then this was the middle one. And then this was the far right one. So we're going to put it in that order. And again, if we were doing this in class and the computer wasn't grading everything, you know, not everything, but a lot of things that you do, I really don't care about the order so much. But this is just so that we stay consistent in the way that you're going to type in your answers, so that there's no confusion about why you missed this or how to put it in the computer. All right, last question. Oh, and then I'm not going to take the time to do it on this video right now because I just, you know, want this video available to you for the content. But just like what we did is you should go through and type in, and you could do this on Desmos instead if it's more user-friendly. Type in this answer. Well, maybe we'll do it. Let's just do it. Never mind. I won't do it for the third one. I'll do it for this one. Or maybe I'll change my mind on the third one. Who knows? Okay, let's type this answer just to double check that we've done everything correct. See, I say that because who knows, maybe I made a mistake. All right, so plus, if you have the newer calculators, it's a lot easier to type it in. If you have the older ones, you got to make sure that you're using the parentheses correctly. Or if you're using Desmos, it's really easy to type it in also. So we have x, what do we have? Plus 3 squared. And then all right, so fingers crossed these are the same. And if they're not, then you guys get to help me figure out what I did wrong. I'm thinking I'm good. It's taken a long time to graph it, but it looks like they are exactly the same. And if you had questions, you could also go to the table. It's still graphing. It's taking forever. You could go to the table and look at the values in the table. Just make sure that they're all exactly the same and they don't change all of a sudden. All right, so that one's good. Last one. Okay, so I look at these right away just looking for a 0 that's easy, and I notice that none of them are integers. They're all in between. So I'm just going to start all the way with the left one and use second trace 0. And I have to pick a left bound. So this one, let's see, to the left of that point, -1, -2, -3. I'm going to even go all the way to -4. It's definitely to the left of it. And you can see this line that opened, that came up. And then -1 is certainly to the right. So it's somewhere in between there. I'll say, I'm going to show you how you don't have to be super accurate. I'm going to say -2. It's definitely not -2, but it's closer to -2. And then it comes up with an answer, -2.5. So x equals -2.5. But we're not going to use decimals. So I don't want this written as a decimal. I'll take that and I'm going to change it into a fraction. You could say -2.5. We do not want a mixed number. So -5 halves. -5 halves is the fraction that I'm looking for. So because it is -5/2, you cannot use synthetic division. You have to use long division. So what we're going to do is we're going to actually find the factor first. I've got x equals -5/2, and the factor can't have a fraction in it. So multiply both sides by 2. And get 2x equals -5, add the 5, 2x plus 5 equals 0. So that's my factor, 2x plus 5. I'm going to change colors so it doesn't get too confusing. All right, so long division. We're going to first divide. So 2x into 12x cubed. Remember, if you need some help, you just go off to the side and do 12x cubed over 2x. And we just reduce those. That gives me 6x squared. Then we multiply by distributing. 6x squared times 2x is 12x cubed. 6x squared times 5 is positive 30x squared. We draw the line. We change the signs, and then we add. Those will cancel out. I get -50x squared. Then we bring it on down, -77x. And we divide again. So 2x goes into -50x squared. If you need to go off to the side, -50x squared divided by 2x, that's going to be -25x. And I'm going to distribute that. I get -50x squared, and then -125x. Draw the line, change the signs. Those cancel. And then, what is that? I get 48x. Then we bring down plus 120. And then 2x goes into 48x 24 times. We distribute, we get 48x. 5 times 24 is 120. Draw the line, change the signs, and we get 0. So that tells me I did it right. The calculator told me that this was the well, it told me -5/2 was the 0. This is just confirming that I did it right, and then it's giving me what's left over. So now, since we have a quadratic, we can try to factor it, or we can just jump straight to quadratic formula if you want. I'm curious to see if that does factor. I think it does factor. So I'm going to try to factor it. I'm pretty sure it factors. I was just playing around with some numbers on my calculator. And if I'm wrong, well, then I'll just go back and I'll use quadratic formula. Let's see. I think 3x and 2x, and then 8 and 3. And they'll both be minus. Let's just double check that. That's going to give me 9x, 16x, which gives me 25. All right, so I've got 3x minus 8 equals 0. 2x minus 3 equals 0. I'm actually doing something right now that I don't need to do. Just out of habit, I'm doing it, but I totally didn't need to even do this. We're trying to write this in factored form. Well, I guess it doesn't hurt to do this, because now this is going to help me know what form to put it in. We're trying to write it in factored form, and we have 3 factors, or 3 zeros, and that's good because my degree was 3. Putting my zeros in order. so I know what order to put my factors in if I have to type it into my calculator. We've got -5/2 first, and then 8/3 and 3/2. This is 1.5, and this is 2 2/3. So it looks like 3/2 comes next, and then 8/3 would be the third one. So that's helping me when I go to write it in my factored form. And this is h of x. Excuse me. This is telling me to write, where's my first one? 2x plus 5. And then right here we've got 2x minus 3. And then our other factor, 3x minus 8. Now, if you chose to do quadratic formula instead, you would just get the zeros, and then you'd have to go backwards to get the factors, which I showed you in the very first question, question A. So this would be the factored form. And again, you could type this into your calculator, make sure that they overlap completely to make sure that you've done it right. So what I would expect, if you have questions, first of all, remember I've got my Zoom hours. That's the easiest way. This is supposed to be an exclamation point. Zoom hours. Easiest way to ask me a question. If you're typing me questions, that's totally fine, but a lot of times it's harder to answer those, or I might not exactly understand your question. So this is the #1 way to get a hold of me. But definitely send me a message if you have any questions. If you're typing this part back in and it's not overlapping, ask me questions. For this worksheet, I'm going to have you type in the factored form for your answers on Canvas. So you need to make sure that you are putting them in this order. All right, well, have a wonderful day, and I will talk to you all soon.